Hi guys. Today we're working on area under a curve, and this is just the beginning of integrals. So in this question, we're going to estimate the area between the graph of f of x, which that's the graph right there, and the x-axis on the interval between 1 and 6. Okay? Now we're going to use 5 rectangles of equal width and right endpoints. That's what this means. R for right endpoints, and 5, that's the number of rectangles. Okay, so we're looking at these points right there. Now we're going to use the area of rectangles just because it's easy to find the area of rectangle. And then I'm going to show you the difference between using the rectangles and actually using the integral on the calculator. There's a slight difference, but the more rectangles you use, more accurate that's going to be. So with only 5 rectangles, that can be very precise. Anyways, off we go. So we need to decide, to begin with, the width of each rectangle. So if I'm looking at the interval between 1 and 6, and I need 5 rectangles, 1, 2, 3, 4, 5. The width is easy. So each one will be with the width of 1. Sometimes, let's say that if we had to get 10 rectangles, the width would be just half because you would need 10 rectangles. The final answer would definitely be more precise, but right now we're just answering this question right here with 5 rectangles using the right endpoints. Okay, off we go. So I like to start with the visual here, and then even if the question doesn't give you the graph, just know that you can always go ahead and punch that in. So I will look for those points right there so I can go ahead and calculate the area of each rectangle, and then I'll add them up to find R5. So I will use f of 2 because it's the right endpoint starting at 1, so the right endpoint will be right there. So this is the first right endpoint. So I'm going to look at f of 2, and then f of 3, f of 4, f of 5, and then also f of 6. The reason why I like to write it out, sometimes you might lose count on the number of rectangles. You just get going, and then you lose focus on the mission, and your area is wrong. So here we go. You have 2 ways to go about this. One, you can just put it in the calculator. And then find the y values for those that you actually need. Or you can just do it by hand, either way. So right here, f of 2 is 4/5. And then 2/5. This is one way to do it, is by pulling the information out of the table, or if you are right there at the graph, you can go trace and then ask for whatever x you want. So right here I want x equals 2, and then it will bring back the y value. And then you do the next one, it will bring it back. So either way, there's that option. Okay, now I know, because think about this. The width is 1. So whatever number I have here times 1, that's going to be the area of that rectangle. So this first rectangle, the area is 4/5. The second one is 2/5. And so on. You get it. Now, for me to find the area of all of them added together. So off we go. So you got 1.6972, some. But let's go ahead and round that to 2 decimal places. So 1.7. So our 5 is about 1.70. So, and you're like, why don't you use the integral on the calculator? Let me show you. So the way you're going to do it, and we're going to compare the two answers. So if you go second calculate the integral, that's that number 7 right there. You're going to get lower limit. So we're going from 1 to 6. So 1, upper limit is 6. And then it will give you the accurate area under that curve. Notice the difference here. Calculator is telling me that it's 2.48. But here with my 5 rectangles, it was 1.7. Why is that? Well, I only had 5 rectangles. There's going to be a difference, okay? So if the function, or since f of x is decreasing, between that interval, between 1 and 6, then R5, with the right endpoints, 5 rectangles, will underestimate the area under a curve. Okay, and you can clearly see that with your math, you did end up with 1.7, and here the calculator gave you 2.48. Okay, so this is the main idea. Now, if you had, I'm going to talk a couple more things here. So if f of x is also decreasing, so the same idea here. But you're using left endpoints, then that would overestimate. You get the idea. Let's do another one. So now we have a square root. We also have 5 rectangles, but now we're going to use the left endpoints. Here's the visual, so we're using these endpoints right there. So let's say that if you don't have a graph, go ahead and draw yourself a number line. It's just easier to visualize that. So you're going for the interval right here between 0 and 5. You need 5 rectangles. Same width. And then you have to use the left endpoints. So between those rectangles, you're going to use 1, 2, 3, 4, 5 endpoints. So just as a reminder, you're going to use anything between f of 0 and f of 4, not f of 5. Okay, it just turned out that, again, the width will be 1, which that's also really nice when that happens. So I have 3x plus 2, and it's going to be a whole bunch of decimals. So it's up to you if you want to just use the numbers from the calculator, or if you want to actually do the math and use that in terms of the square root. Either way, I would wait until the end to round your answers. So I'm going to use 4 decimal places, just because I'm going to wait until the end to round that information. So f of 0, that's 1, 2, 3 rectangles. Did I skip one? So this is f of 0. This is f of 1, f of 2, f of 3, f of 4. That's why I write it down, because sometimes you're going to have 8 rectangles. So just make sure that you are using and you're stopping where you need to stop and you're using the right numbers from your table. So now we need to add them all up. And in this one, we have 3.54 if we're going to round to 2 decimal places. So L5 will be approximately 13.54. That's all I got for you.